Here's some nesting material here, but more importantly is it's a thick layer of mouse poop and nuts, nut shells. It's disgusting. So I'm gonna clean all of this out. And then I'm gonna work on this wiring. All right, so I was able to use the shop vac to get a lot of this debris up. Turns out underneath all the mouse stuff, there was just a layer of mud. What I did notice though, which could be a problem, is right here, there's a stud with a very, very rusty nut on it. And that attaches these eye connectors, these eyelet connectors on these 4 wires here. So what this is this is a chassis grounding point. So this being all corroded could cause problems. So I definitely, while I have this all open, I'm going to want to see what I can do about addressing that. My fear is that it is so rusty that it's just going to snap right off. No, maybe I shouldn't touch that. Unless I actually, in the process of diagnosis, determine that that could be the fault. Well, then obviously I'm going to want to do something about it. This is a safety switch right here that basically determines whether or not the parking brake is set. This tractor will not start or crank if the parking brake is not set. So it's important that this works properly, and it turns out these are magnetic. And the reason why I know that is because they're all little bits of rust and stuff that were falling off of this assembly when I was pulling it all up and everything, that immediately chose to get attracted to and stick to this thing. So I'm going to make sure that that's clean when we put this back together, because obviously it's not going to work correctly if it's clogged with metal. So if the system thinks that the parking brake is on, what happens is you can't shift it into drive, because the shifter on the column here, it's all electric. All the shifting is done with solenoid valves in the hydrostatic transmission. That's how I kind of knew this sensor was working. If this was my problem with it not cranking, then when I did finally just like jump start it and get it running, and I had the brake on and it wouldn't move, that's what told me that this was working. All right, so that's cleaned out. But what really gave me pause is what I saw here. So let me move this wiring back in position where we can see it better. So this is all filthy with mouse debris that I cleaned a lot of it off, but there's still crap in here. And I mean, I'd love to just blast this with water to clean it, but of course then I'd be blasting water right up into the backside of all of these connectors, which all of these connectors right here are for the relays. This block right here, the plastic piece is broken off, so, and it looks like, well, that just clicks into this other one, but this piece right here is broken off of here. But this is what caught my eye. Look at this. So this is a wire that used to be red that has had all of its insulation removed, probably by mice. This wire is a Mickey Mouse jumper somebody stuck in here by the looks of it, because it goes over to this yellow wire with a wire nut. That's not factory. And it fell off of this wire right here, which I can see is also yellow, that goes to this relay. So that's interesting to me, because I'm wondering if that is the neutral start relay that tells the system if it's in neutral. Furthermore, I can now see that this wire is all exposed. This wire is exposed and very close to shorting out against that wire. This wire is all exposed. So the mice have really been at it in here. So I'm just going to use some of this electromotive electric parts cleaner to, and a brush here, to see if I can clean up some of this crud. Oh, that's dumb. What that's going to do for me is that'll expose these wires better, so I can make sure that I don't have other ones that I missed here that are chewed. But no, it all looks pretty good. It looks like it's all confined to this one little section right here, which is good. That much less I have to deal with. I'm gonna remove this little bit of tape and this little bit too. This way I can separate the wires a little bit. Get a better gander at what's going on here. Oh, that one's chewed too. This one's chewed on this side. Since all of these wires, or the majority of the wires that need repair, are going to this relay, let me see if I can identify what that relay is. So it's the upmost top left. I don't remember if there's a diagram on the inside of that cover. Probably not, that'd be too easy. No, there isn't, but there's one in the owner's manual. Alright, so this relay with all the wiring mess here is the ignition relay. And the fourth relay down, which is 1, 2, 3, this one down here, is the neutral start relay. So unfortunately, this will not actually account for any of my issues with the not cranking from the key, because it turns out I got the diagram, and it's a really basic circuit. Power comes in from the battery, goes through a primary fuse, which if the primary fuse was blown, I wouldn't have my electric fuel pump running or any of that stuff going, and my lights and stuff wouldn't work. Goes right over to the ignition key, and then when the key is turned to the crank position, that sends power out on this line, which goes through the neutral start relay if the neutral start relay is closed, and then right to the solenoid. Funny thing is, when I look at what the ignition relay does, the things that it feeds, it actually feeds some things that I'm not even really using. But some of the things it feeds are some lights, but I think most of my lights are working. So I'm wondering if this wire just came off, like when I was working on this now, taking it all apart while working on the throttle cable. Yeah, I can hear the electric fuel pump running, so I know I've got power coming up to the ignition key. When I crank this, it should crank the engine, and it doesn't. But just for giggles, I could hook this up. Try and crank it. Nothing. Okay. Also, when I turn the key on, I'm getting these dash lights right here. I wouldn't be getting those if the primary fuse was blown. So according to the schematic, that yellow wire that I just hooked back up to the starter solenoid actually looks like it goes through a connector somewhere and then goes right over to this neutral start relay. And there's only 4 wires going to the neutral start relay according to this. So here's the neutral start relay right here. Let's pull, oh look at that. That's actually loose. Well, how do you like that? Plastic retaining clip for this was not clicked in. Alright. Oh, could it be that easy? Just reseating that relay? Nope. Okay. So, let's see if I can unplug this relay. See what the contacts look like. Ooh. Oh yeah. Interesting. There's 5 connectors on here, even though there's only 4 wires that go to this. Supposedly. Let's clean up these contacts. Alright, I cleaned up the contacts pretty decent on this side. Yeah, see if that's going to be good enough. So this can only go in this way. Alright, let's try this again. Still nothing. Okay, so what I'm going to do is I'm going to turn the key on. I'm going to shift the drive lever on the side of the steering column, forward, reverse, neutral, and see if I can feel this relay or hear this relay clicking. Oh yeah. Sounds like it's clicking. Let's pull it out and see if that clicking noise goes away, just to confirm that is the right relay. Oh, it's not. This is a different relay. What the heck? This one doesn't seem to be doing anything. So the problem I have with that wiring where the mice chewed off all that insulation is that they chewed off the insulation right up to the back of the plugs or the sockets for these relays. So there's really no way for me to cut that wire back, and the wire's damaged anyway, so I would want to put new wire in. So I decided it would just be easier to replace those relay sockets. Now, those relay sockets are part of the wiring harness on the JCB. So JCB probably has some sort of a part available that is like a repair, because I got to imagine that they don't expect, if you had a malfunction that caused like the plug to melt or something like that, they're not going to expect you to replace the whole wiring harness completely. But the way those all interlock together makes them kind of unique. And even if I could figure out what the JCB part number is, based on my experience with the cable price, the throttle cable price that I was hit with, I would say it's probably going to be pretty darn expensive. That being said, these relays right here, I took all 4 of them out because I'm going to test them right now. These relays right here, I was able to identify these relays and just barely make out a number, 70630, and then I can't quite make out the last few digits, but then I was able to plug that in and find out that it's actually a 30148 is the relay. Now, I found those come up as JCB part numbers. When you just plug into Google 716 is 30148, a lot of JCB branded relays come up, but also a lot of generic relays come up. And the reason why is because this is a pretty standard 5-pin relay. And we're only using 4 pins on this because, again, this is a dual throw relay. So you actually have continuity between here and here. I think if I've got the pinning right. When the relay is not energized, and then when 12 volts is applied to here, you end up with continuity between here and here. Well, we're only concerned with having continuity between 2 points when it's energized. When it's not energized, we basically want an open circuit. Getting back to the wiring harness problem, since we know that this is a generic 5-pin relay, which is pretty common use in a lot of different circuits, including some older automotive stuff, I was able to procure this at my local auto parts store. This is from Napa. This is a brand, Grote, G-R-O-T-E. I am Grote. And it's a model 84-1041 5-pin relay pigtail. 14 gauge wires. So the 14 gauge wires is the only thing I'm not sure on yet, because 14 gauge wires means it's for maximum of 15 amps DC, which most of the things that run in that backhoe off of these relays should have no problem running at well below that. And actually you do want to keep it probably like at really 12 amps max, because 15 amps is maximum, but you want to try and derate it a little bit. So just for the sake of argument, as long as everything that is fed by these relays doesn't exceed 12 amps when it's running, or when those items are on, I should be good to go with this type of a plug. Take the neutral start relay here, for instance, as an example. All that this relay's contacts are carrying for current is the current that's drawn by the solenoid on the starter motor, not the actual starter itself. Remember, that current for the motor and the starter is actually going through the solenoid contacts, Just the electromagnet inside the solenoid that closes it is what's drawing current through here. The other issue with this plug is these don't all interlock together really nicely like the other ones do. That being said, I'm not going to worry about it. I'm just going to keep the wiring harnesses kind of taped together and tuck it into that compartment. And, you know, on the rare occasion when I need to change one of these relays, it'd just be a matter of reaching into that compartment and pulling them out individually or whatever. So I'm not going to worry about that. Before I get started with doing the job of cutting those wires back, and I want to do a really good professional job, I'm not going to use wire nuts or anything like that. I'm going to make sure that these splices are going to be covered with heat shrunk tubing. It'll look really good and be pretty well protected when I get done. But before I do that, I decided to just mock up a little test here on my bench so that I can test these relays and make sure they're all working. Main reason I want to do this is because if I have a relay that's acting up, obviously that could be part of my problem. But furthermore, turns out at Napa, where I got this for about $9, for about $14, you can get the same wiring harness with a brand new relay. So before I buy any more of these, I want to see whether or not I need any relays. So this is going to be a really basic circuit that I hacked together here on the bench. This is my high elec model HY1803D variable voltage power supply. This is a current limiting power supply, so I set it to 12 volts, and this is going to be my source for the test. It's going to act like the battery. All right, so the orange wire we can ignore because the orange wire is this very center pin, which is the normally open contact, so we're not concerned with that because it's not used in this application. So the two contact connections are at the yellow wire and the red wire. So right now I have this wired so that the yellow wire is hooked up to the power supply on one end, and the red wire I have going over to this 12 volt solenoid, and then from the 12 volt solenoid's other connection goes back to the power supply, so that if we were to close the contacts, this solenoid will energize. I wanted to put a light over here, but the problem is I have a bunch of 12 volt bulbs here, but I don't have any sockets, so it was just easier to hook up to this. And it's really pretty straightforward. When this gets 12 volts, it makes a pretty good sized loud click, so I know that it's closing. Now I've got the blue and the green wires here. These are the two connections to the actual coil inside there with the little electromagnet that when that sees 12 volts will actually pull those contacts closed. So I've got that one of those hooked up to the power supply now, and the other one I just have floating here. So when I stick this in, what's happening is this relay is being energized, closing the contacts and sending the 12 volts over to the solenoid, which is what that loud click is you hear. So that's a good relay. So all four of my relays are good. So now I know all I need are replacement plugs. I don't have to buy the plug relay combos. And I'm not going to replace all four of them. I'm only going to replace I think it's two of them that need replacing. All right, so I've already prepped this one by sliding over a piece of heat shrink tubing on each wire and then crimping the connectors on, the butt connectors. This way all I have to do at the machine is cut, strip the end of the good wire, crimp it onto here, slide this back over it, and then use the heat gun to shrink it. So because I have 14 gauge wire on the new connector, but 12 gauge wire for two of the connections on the machine, I need to use these larger butt connectors. I've got these smaller ones, but these are only good for 14 to 16 gauge wire. So I've got to use these bigger ones. The problem then becomes, I want to put shrink wrap over them. I've got to use these larger shrink wraps right here. And then what ends up happening is when I shrink them down, they shrink down enough to go over the outside of the insulation on the large wire, 12 gauge wire, but they don't tighten around and make a watertight connection around the 14 gauge wire. So what I'm going to do is I'm going to use these smaller sized heat shrink tubing, which will be able to shrink down about around either of those 2 wire diameters, but they won't fit over these. So what I'm going to do is I'm going to take this plastic piece off, because this plastic piece really doesn't serve any purpose once I have a nice heat shrunk piece on there. So it's just a matter of using a sharp pair of diagonal cutters and peeling them off. And sometimes it's easier to just grab it with some needle nose pliers. That's what I want. Alright, so out of the 4 relay sockets, these 2 don't appear to have any damage to the wiring, so I left those 2 alone and I replaced these 2, which is what you're looking at here. So I also cleaned up the terminals on these relays. Okay, still not cranking. So my problem wasn't the wiring. Well, actually, I shouldn't say that. So after I quit last night, before I went to bed, I ended up going up to my desktop and pulling up my service manual that I had purchased for this machine. And was looking at the wiring diagram again, and then looked at some other things in the manual that actually explain a lot about how to work on these machines and what the thought process was of the engineers. So like one of the things I was mentioning earlier on was the fact that, you know, all of these wires are yellow. Then I noticed that there were numbers printed on the sides of all of these wires. And come to find out, that's exactly how the engineers intended for you to be able to identify these wires. They made them all yellow, but they put a number on the side of every single wire, and that number repeats every couple inches or so. So on any one of these wires, you can find a number. In fact, there's actually other numbers on there too. There's even a number on there that would denote which wiring harness that bundle of wires is part of. So that was a big help. And then when I looked at this is the schematic I looked at. Oh, I want to mention something else real quick. I think earlier on in the video I mentioned something about the parking brake not having to be set to start the motor. That's not true. The reason why I said that was because the power comes from the switch, goes through the neutral start relay contact and goes directly to the motor. But the neutral relay start, the neutral start relay can't be energized unless it's getting voltage to its coil. And if you look right here, this actually goes to park brake switch. So they are actually using the park brake interlock to control this relay as part of what controls this relay. So you have to be in neutral, and your parking brake has to be set before the engine will crank. So I enlarged this section of the diagram. So this is wire number 842. So remember when I was looking at the relay last night, I knew that the 2 larger wires are the ones that carry the current and are going to go to the contacts, but I didn't know which wire was which. Well, now I'll be able to look at it and figure out that, oh, okay, the one that's printed with 842 on the side is the wire that's going to eventually go to the starter solenoid. On this side, there's a wire that's 004. That goes over to the key switch. The key switch is just off the picture right here. So that's the plug I was working on last night, trying to find continuity to the front. Now that I look at it, I could see that one of the 2 wires, the thicker wires going to it, is marked 002. And the other one is marked 316. So that's not even the right relay. Well, turns out I wasn't wrong in thinking that this should be the neutral start relay, because then I found the page in the service manual that shows the layout. Number 1 is at the top, number 4 is at the bottom. But on here, it says number 4 is the neutral start relay, which means the neutral start relay is actually one of these 2 that I already replaced. And sure enough, this one right here, if I go where I spliced into the original wiring, there's 004 that goes to the key switch right there, and there's 842. Son of a gun. There it is, 842. So I tried this, I tried starting it after I replaced the bad wiring and wired in the new relay sockets. But what I forgot is that my parking brake isn't set. I've got all my relays plugged back in. So now course, it's not going to work. But I have the parking brake not on. So what I'm going to do is I'm going to turn the key on, and I'm going to turn the parking brake on and see if one of these relays clicks. Well, it should be the one I just discovered was 842. This one. So this relay should close when I engage the parking brake. It does. Alright, so now I really have mixed feelings about what's about to happen, because if it starts right now, then it means I had this fixed about 2 or 3 hours ago yesterday, and I just didn't realize that I was focusing on the wrong darn relay and that I forgot to set the parking brake. My battery's low, but it's cranking. This is fixed. So where my problem actually lied was in the bad connections due to the mouse chewed wiring on this relay. Well, I think that's going to call this one a wrap, guys. All I have to do now is put this thing back together, and we'll be good to go. Alright, so hopefully you guys found this video at least entertaining, if not helpful. Take care.